In this video we will practice solving trig equations such as this one. In the previous two videos we have already done problems 1 through 10. So if you haven't watched either of those videos, you might want to check those out first. Make sure you know these Pythagorean identities by heart. Alright, be able to take a sheet of scratch paper and write all of these down exactly the way they look. Also make sure that you've memorized these facts. Alright, the easy thing about number 11 is that we have all sine function right from the start. So I can go straight to the part where I factor. 2 sine squared x. That can only be 2 sine x times sine x. And then I see the number 1. That can only be 1 times 1. Now inner plus outer must equal the middle. Inner I have 1 sine x. Outer I have 2 sine x. That must equal the middle, which is 3. For that to happen, both of these need to be positive. So that means these are going to be positive. Okay. I also have to check and make sure that positive 1 times positive 1 equals positive 1. Now I can set the factors equal to 0. So 2 sine x plus 1 must equal 0. And sine x plus 1 must equal 0. Subtracting 1 and dividing by 2 gives me sine x is equal to negative 1/2. Subtracting 1 gives me sine x is equal to negative 1. Okay, here's a little circle to picture. What is the reference angle for this first one? Well, sine of pi over 6 is 1/2. So pi over 6 is the reference angle. So thinking of pi over 6's, keep that in your mind. Now, it's negative 1/2 though. So where is sine negative? Well, I know that sine is negative below the x-axis. So quadrant 3 and quadrant 4. So these are the two angles that I'm looking at. So right here on the left would be 6 pi over 6. So if I go one more, that would be 7 pi over 6. So that's going to be 7 pi over 6. And right here, if I went all the way around, that would be 12 pi over 6. So one less than that is 11 pi over 6. Okay, in addition to that, I need to know where sine is negative 1. Sine is a y value. Y values are negative 1 at the very bottom of the unit circle. So that is 3 pi over 2. So I'll add that on to the list. 3 pi over 2. And there is the complete solution for number 11. Watch out now. This problem is going to be a little bit extra tricky. I see that I have sine and cosine. So I have to fix that. But unfortunately, neither one of these is squared. So that's going to make it really tough to use my chart of identities where everything is really squared. So what I need to do is I need to square both sides of this equation in order to create something that I can then substitute. But watch out, let me say this right now. Whenever you go squaring both sides of the equation like this, you might have extraneous solutions. So you're going to have to check your answers to make sure that they actually work. So here I go squaring both sides. I must be very careful about this. This won't just be sine squared x plus 1. When you square a binomial, you really have to multiply it out. Sine x plus 1 times sine x plus 1. Now, of course, this is just the same thing as having cosine squared x. Alright, but this I need to FOIL it or double distribute, whatever you want to call it. But if I do this, I'm going to end up with sine squared x. You know how I always say inner plus outer equals middle? I can use that right now as well. Inner, I have 1 sine x. Outer, I have 1 sine x. So together, that's 2 sine x. And then the last, if I multiply those, it's going to be 1. And this is equal to cosine squared x. Alright, now the majority of these terms have sine, so I would like to take my single cosine squared and substitute that. Okay, so cosine squared, you say? Yeah, that's what I said. Cosine squared is equal to 1 minus sine squared. Okay, so I could put 1 minus sine squared x over there. Meanwhile, I have the rest of this still. Plus 2 sine x plus 1. Alright, now I need to move everything to the left, so I need to subtract 1 from both sides, and I need to add sine squared x to both sides. So that's going to give me 2 sine squared x plus 2 sine x. These cancel out though, don't they? So that's just going to be equal to 0. Now, when I factor out the GCF, I could keep this 2 off to the side, or I could divide everything by 2 right now. Alright, if I were to sit here and just divide everything by 2, that would immediately give me sine squared x plus sine x is equal to 0. I do not have to keep the 2 hanging around. Alright, now I will do the GCF. So I will take out the sine x, and that will leave behind sine x plus 1. Okay, now I will set these factors equal to 0. So I will set sine x equal to 0, and I will set sine x plus 1 equal to 0. Subtracting 1, I have sine x equals negative 1. So where is sine equal to 0? Where? I'm glad you asked that. Excellent question. Okay, should I put this over here? Quadrantal angles. Sine is a y value. Y values are 0 on the x-axis. So that leaves me with 0 and pi so far. But then I have sine equaling negative 1. Y values are negative 1 down here at the bottom. That is 3 pi over 2. Before I put a box around this and think I've got the answers, I need to check these answers. And again, the reason why I need to check them is because we squared both sides, and that can create values that don't actually work in the original equation. We changed the equation. So just all of these three things would work in a squared equation. But if one of them is positive and one of them is negative, we wouldn't know, because squaring both sides will take away the negative sign. So we need to investigate. So I'm going to start with 0 and check it. Okay, so this is me checking. I have to check x equals 0. Alright, so looking at the original problem, that would say that sine 0, I almost made it a theta, plus 1 is equal to cosine 0. Well, sine of 0, okay, sine of 0 is 0. Alright, because sine is a y value, and a y value is 0 right here. So this is 0 plus 1 equals cosine of 0. Cosine is the x value, so that's going to be 1. So that gives me 1 is equal to 1, So that checks out. Alright, so the first one is okay. Alright, now I'm going to check x equals pi. So that would be, and I'm copying off of this so I don't have to scroll up all the way up. So this would give me sine of pi plus 1 is equal to cosine of pi. Okay, well, sine of pi is 0, alright? It's the y value. So I have 0 plus 1. Now, cosine of pi is negative 1. Wah, wah. Because cosine is the x value, and that's negative 1 right here. So that gives me 1 is equal to negative 1. Wah, wah. That did not work. Okay, so that means pi is not a valid solution. I'm going to get rid of it. Now I need to check x is equal to 3 pi over 2. So that's going to give me sine of 3 pi over 2 plus 1 is equal to cosine of 3 pi over 2. Whoa, I'm really running out of space down here. Anyway, sine of 3 pi over 2, that is a y value. So that's going to be negative 1. So I've got negative 1 plus 1 equals cosine of 3 pi over 2. That's an x value. So that's going to be 0. Okay, so that's giving me 0 is equal to 0, which does check out. Alright, so that leads me to my final answer, which is simply 0 and 3 pi over 2. Alright, so these are the only two answers, and the only way we could know not to include the pi is that we checked them all. Okay, we have secant squared x minus 1 is equal to 0. I'm just going to add 1 to both sides, so that's going to give me secant squared x is equal to 1. Now I'm going to take the square root of both sides. Don't forget your plus or minus. So that's going to give me secant of x is equal to plus or minus 1. Now I'm going to take the reciprocal of both sides. So that's going to give me cosine x is equal to plus or minus 1. The reciprocal of 1 is 1, and the reciprocal of negative 1 is still negative 1, so this doesn't change. Okay, so what do we have here? Well, cosine is the x value. So it is 1 here, and it is negative 1 here. So these are the two values that will give me a positive 1 or negative 1. Nowhere else. The other two quadrantal angles would give me 0. So that is 0 and pi. So those are the two solutions for problem number 13. Alright, for problem number 14, I need to subtract 2 cosecant from both sides. Do not ever think you can divide both sides by cosecant x. Alright, that is a common mistake. You cannot divide by a trig function. Instead, you have to subtract it. So that will give me secant x cosecant x minus 2 cosecant x is equal to 0. And what you want to do, that thing that you were tempted to divide by is now a GCF. So we will take out the common factor of cosecant x. and that will leave behind secant x minus 2 is equal to 0. Now, setting these factors equal to 0, I have cosecant x equals 0, and I have secant x minus 2 equals 0. Adding 2 to both sides gives me secant x is equal to 2. Now, taking the reciprocal of everything, I can't really take the reciprocal of this the way I want to, because the reciprocal of 0 is undefined. You know, if you take the reciprocal of something, you put 1 over it, and 1 over 0 is undefined. That really tells me that cosecant x has no solution. Okay, because cosecant, of course, is 1 over the sine function. So this is really saying 1 over sine is equal to 0. Now the denominator cannot equal 0 because you can't divide by 0. And the numerator is 1. So the denominator can't be 0, the numerator is 1. If you have 1 over something that's not 0, you're never going to get 0. Basically the numerator has to be 0, and it's not. So there are no solutions coming from this part. Okay, so I have to focus on the right hand side. I can take the reciprocal of both of these. So the reciprocal of secant is going to be cosine. So I'll have cosine x, and the reciprocal of 2 is 1/2. So now I've taken the reciprocal of both sides. So the reference angle here is pi over 3. All right, I know that the cosine of pi over 3 is 1/2. Come on. Okay, so in my mind, I'm thinking about this. All right, here's a little picture. Okay, I want positive, positive 1/2. So that means I want to be in quadrant 1 or quadrant 4. All right, the right hand side is where cosine is positive. Now the reference angle is pi over 3. So this angle right here is the reference angle of pi over 3. So I can go ahead and write that down. Now this one down below, if I went all the way around, this would be 6 pi over 3, because that's 2 pi. If I stop one short, that would be 5 pi over 3. So this one would be 5 pi over 3. So these are the only two answers to problem number 14. One more. Number 15 is very interesting. I need to divide both sides by 3. So that's going to give me cosecant squared of 5x is equal to negative 4 over 3. Now really, as far as I'm concerned, this is the end of the problem. I'm going to go ahead and say no solution right now. Because look, if you square something, it's going to be a positive number, no matter what. So here I am squaring cosecant. It doesn't matter what this is, the 5x, that makes no difference. If you square something, it's positive. There's no value of x that you can square this and have it be a negative number. So immediately you get no solution. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.